Linked lists are not that easy, so let's deal with them today. So the problem today is going to be problem 21 from Leetcode, merge two sorted lists. We are given two sorted linked lists, list 1 and list 2. The example that is given, I don't think is super nice for explaining purposes, so let's take another one. Let's say 1, 2, 5 is going to be list 1, and then something like 3, 7, 8, and 10. That is an 8. Just believe in me. That is an 8. So what we're going to do now is that we are going to take those two lists and we are going to merge them together. What do we mean by that? We are going to have a resulting list that is also sorted with every single node we see here. So the algorithm that you're thinking about is probably the right one, meaning you have simply a pointer at the beginning of each list and then you compare the values. You take the lesser one and you add it to the output. So here it would be 1. Then what do? We simply, oh, my bad. We simply shift that. That is my bad again. What I wanted was to do this. We simply shift that pointer here. And we're going to do that until both of our pointers are out of bounds. We have reached the end of the list. Let's go through it until we can't anymore. So we already added those two nodes to the resulting list. Then we have the comparison between 3 and 5. So we select the 3. We shift the pointer of list 2 one space to the right. Then we have the comparison between 5 and 7, and then something interesting happens. We're gonna need to shift something in list 1 that points to absolutely nothing. And there is a little trick, is that now that you're done with iterating over one of the lists, the other one is already sorted. So what you can do is simply take all of this sublist here, and that sublist can simply be added as the next logical step in the output. So here we would simply transpose this ensemble of nodes here. So it would be 7, 8, and 10. Okay, so that's one of the two little subtleties of that problem. The second subtlety, except dealing with linked list, which once again not that trivial, is gonna be to think about an edge case where imagine you have two lists and they are just empty. How do you merge that? You're gonna fail to perform the first comparison here. So what we do is a little trick, is that we start with a dummy node. So you have a dummy node at the very beginning that is a node that doesn't have any value and that doesn't point to anything. And then that node, we're gonna exploit it by simply making it point to our output. And we're gonna return only what follows it. So let's see how to implement that. Alright, so we are back for the code implementation. First, let's initialize the dummy node. So everything is gonna build around that as far as our output goes. So simply it's gonna be a list node that doesn't contain anything. We're going to initialize a tail. So a tail is simply what we're gonna make grow. It's gonna yield that part right there. This is going to be created by the tail. So first, when both of the original lists are still not empty, we're going to perform the first part of the algorithm where we compare nodes one by one and we see which one to add to our output. So this is simply written as, well, list 1 and list 2 are not empty. Then we need to compare those two nodes, right? So the first node of the remaining lists. So it's simply going to be list1 dot value and we are gonna compare it to list2.value. All right. What if the value of the node, the first node of list1 is less than the value of the first node of list2? Then we're gonna append the value of list1 to the output. So tail.next is gonna be equal to list1. And then we're gonna shift the pointer one step to the right in list1. So list1 is equal to list1.next. Okay? List1.next. Otherwise, we're simply going to do the same, but with list2, because we want to pick the node of list2. So let me simply copy paste this right there. Exactly the same, but we take it from list2 and we shift list2. Alright. Then we simply shift the pointer in the tail, meaning that we have computed the first node. Now we are happy with it, we shift and we're gonna compute the next node. We're gonna do that until one of the two lists is empty. One of the two lists, the pointer is gonna point towards nothing. When that happens, it's time to take the remaining list and add it at the end of the output. So, for instance, if list1 is empty, so if list1, so that means that list2 is empty now and there is only list1, because we are out of the list1 and list2 condition, we only have list1 left. Just add it to the output. So tail.next is gonna be equal to list1. Else, if list2, just add list2 to the output. And now what we need to return is the tail, so everything that was built by the tail, but the tail right now is pointing towards the last node that was added. So what we need is to point to everything that is after the dummy. Everything that is after the dummy, which is the beginning of our list, meaning dummy.next. That's what we return. Return dummy.next. And hopefully that will compute. Exactly. So let's submit it just to see. So yeah, Leetcode metrics are not the best. We have 0 millisecond of computation, which I doubt, but this is a pretty optimized answer and it computes pretty well.